My name is Jimmy Bogard. You can find my talks and presentations on my GitHub at github.com/jbogard. You can also follow me on Twitter at @jbogard, and I blog about this and a lot of other topics on my blog at also jimmybogard.com. So this talk is a story of distributed system failures and some patterns and practices we can put into place to help, I wouldn't say to eliminate those failures, but help to address them. And this story actually starts off with a developer colleague of mine. We'll call him Bill, mainly because that's actually his name, Bill. Bill came to me with this really worried look on his face, like he was almost sweating. He was so worried. Now, Bill is a pretty kind of straight-laced, even-keeled sort of person. So if he comes to me looking really worried, like some developers are pretty high-strung, and I'm like, okay, I'll talk him down. There's nothing really wrong. But if Bill comes to me with a worried look on his face, I know something is really, really wrong. So he comes to me and says, hey, I'm reviewing some code for a client that is for an e-commerce website that's about to get shipped, and I saw some stuff that had me really, really worried. I said, okay, Bill, I believe him because, again, he never gets worried. So I said, okay, let's grab a conference room, put the code on the screen, and then just show me what you're talking about. Just walk me through what you see here. And so he showed me these just little six little lines of code that looked so simple and innocuous, but hid a lot of really big problems underneath the covers. And so I've kind of distilled it down to these 6 lines of code. Now, these are the most important 6 lines of code in this application, because this is the part where they click the button that says, place order, and all the stuff happens to actually take their money, process their order, and do everything. So if this page doesn't work, then the company doesn't make money. So it's very, very important that this set of code works. So I said, okay, Bill, just walk me through what you see here and just kind of walk me through what's going on here. So he says, okay, the first thing we do as part of processing a payment when they click that very, very important button is first we grab the customer from the database. So they have some cart information, they hit place order, so we're going to go grab some information out of the database. I said, okay, nothing too bad here. And so we're going to go ahead and take that customer information and the cart information and create an order based on the cart and customer details. Like, okay, so far so good. So, okay, now that we have their cart information, we have the total, now we're going to go ahead and call the Stripe payment service to post a payment to Stripe. It's like, okay. Next, after we successfully call Stripe, we need to tell the customer, hey, thank you for your order. So in this case, we're using an email service called SendGrid to go send the thank you email to the customer. Now, finally, we actually need to notify downstream systems to be able to actually process the order and ship it out the door. So in this case, we're using RabbitMQ to publish a message saying, hey, we've created an order. Now downstream shipping service go actually process it. And then finally, we redirect the customer to a thank you page. Thank you for your order, blah, blah, blah. Around all of this is a database transaction. You don't see it here because it's part of every single request, but that's one thing you have as part of this as well. Is around all of this, we have a database transaction to make sure everything succeeds or fails. So based on these 6 lines of code, you should either be really worried about what's going on here or very interested in what's actually going to happen here. So nowhere in any of the 6 lines of code did you see any kind of try-catch. Nothing in here assumes that any kind of failure can occur. Everything just assumes that everything will succeed all the time, forever and ever. And there's one thing that I've learned from building a lot of distributed systems is that failure is always an option for these kinds of systems. In fact, Google still goes down. Gmail can go down. So if Amazon, Google, and Gmail, if those things can still go down, what hope do we have as mere developers? So this code just assume that everything has not 5 nines or 6 nines of uptime. It just has 100% uptime all the time. And so for some code, that could be okay, but for something like this where I'm calling my systems and other people's systems, then I have to start to really think about what happens when those other systems go down or if they fail. So I had him walk through this. Okay, yes, there's nothing in here that deals with any kind of failures. So let's just walk through each of these different calls in those 6 lines of code and say, what happens when each of those lines of code fails for whatever reason? And I'm being very explicit with my language. I don't say what happens if that system fails, I say what happens when. Because when developers, and especially the business, when they hear if something fails, they get these like happy ears and like, no, nothing ever fails, ever. That's such a remote possibility that let's just like sweep it under the rug and who cares. And so I'm being very explicit to say when something fails to force developers and our business to think about those situations. So I broke it down, and we started to whiteboard everything that's going on here. And we broke it down to those 6 things that were going on here. And so I wanted to do is basically for each line of code in there, what happens both from the system perspective as well as the end user perspective when each of those calls fails. So the very first call that happened was I would go grab information out of the database, the customer information, and then I would insert an order. So what happens when that call fails? Well, I don't have any try-catch, right? So some exception happens, but we were wrapping everything inside a database transaction. And so the database transaction would never actually commit. So in this case, if that call fails, then the transaction rolls back. A not very nice error shown to the end user, which is still a problem, right? Like an error shown to you when you just put your credit card information in is like the worst thing you could possibly see. In fact, I start to go like check my credit card statement and say, uh-oh, something failed here. So still not a good thing from the end user perspective, but at least the system is still in a consistent state. I said, okay, now let's move on to the next call. What happens when that call to Stripe fails? Now, we start to look at this and say, well, what's a real possibility that something like that can actually happen? But it turns out that because we're using just a web API call, we could have the possibility that we made a call to that API. We assumed that it failed because we just timed out from waiting for a success result to come back. And we said, well, I tried to call Stripe. I waited for 30 seconds, and nothing happened, so I'll just assume that it failed. But it actually could have succeeded. So even this is a partial success, partial failure state. But just assuming that something went wrong for whatever reason, what is the experience for the end user? Well, because we get that exception, the database transaction never commits, the transaction rolls back, and we think that no money actually is posted to the account. So far, like it's still not a great experience for the end user, right? We never want to show the end user that yellow screen of death from ASP.NET, right? That we never ever want to show that to the end user, especially when they're putting in their payment information. So it's not a great experience for the end user, but at least the system is in a consistent state. Now this is where things get interesting. What happens when SendGrid fails? Very bad things start to happen because we made the call to the database to insert an order. We made the call to Stripe. The Stripe call succeeded. We tried to tell the customer about it, but SendGrid failed. Because we get an exception, the database transaction rolls back, but we still took their money. So not a good thing. So the customer says, oh, okay, I got an error page, and then I go check my credit card statement, and it says that I paid for this. So what do? They call customer service or email them saying, you took my money, but where's my stuff? Where's my order? The customer service rep or admin goes and looks in the system and finds there's no order. Again, not a very good state to be in. At this point, the customer's mad. They're probably going to go onto Yelp and write really bad things about your business, all because we didn't have anything that dealt with that failure over there. What about RabbitMQ? This is where things start to really get bad, by the way. So in this case, the call to the database succeeded initially, but the transaction rolls back. So again, we don't have any record of their order except probably some logs, I guess. Like that's when you know things are really bad, if you have to go through logs to see where their order was. We took their money, and we told them about it via SendGrid, but we have no record of the order, so we never notify any downstream systems. They have an email saying, hey, you actually took my money, and you said here's the order, but when we go look up at the order in the database, it doesn't exist. So again, a very, very bad state to be in. Expect lots of bad Yelp reviews from this as well. And the final really bad thing that can happen is what happens when the database transaction fails. Now, this can still happen on occasion. Let's say we have like database constraints or just some kind of hiccup happens talking to the database. In fact, if you've ever used Azure SQL, you have to really just expect failures all the time with that. In fact, some of the connection providers will just retry like 5 times because the connections could be so spotty there. So even though like in real life we may expect transactions to always succeed, in practice, those transactions can fail. So in this case, what's the experience for the end user? Well, we charged the customer, and we told them we charged them and said thank you for your order, and we notified downstream systems, but the transaction rolled back, so there is no record of the order. So at this point, the system's state is royally effed at this point. There's no record of the order in the database. Downstream systems are trying to fulfill an order that doesn't exist whatsoever. And so basically everyone is mad at us because of the things we've done here. So we walk through each of these like, okay, maybe we can deal with a Stripe failure, but as we start to touch more and more systems, the system gets more and more in a bad state. And so at this point, Bill and I are like, okay, what do we do now? Right now, what's our strategy for dealing with failures? Meh. Like, well, we'll try again next time. But this like shrugging our shoulders and like, it can't actually fail. It's probably not good for business. And again, this is when you start to see things show up on like front page of Hacker News because all these things went wrong. I have friends that have built systems just like this, and they've lost thousands and thousands of dollars because of these kinds of failures. So just like shrugging your shoulders and just assuming everything succeeds is probably not a good idea. Now, the main problem is that we had this database transaction that kept the database transaction consistent, but it didn't touch any of the other systems that we were talking to. So what if we can just kind of extend that boundary of the transaction, just like all the way over to all the other systems we're talking to? That would be nice if that was possible or feasible, but in reality, none of those other systems will support anything like this concept of a distributed transaction. And in fact, the performance, if you ever try to do this, does anyone here ever try to do that, the old like WS extensions, the web service extensions that try to do this? Let's see, there was WS transactions, WS reliable messaging, WS reliability. Like they tried 3 or 4 times to build a web service protocol to be able to do this. They all failed spectacularly. And so this is just not really possible. And on top of that, to try to achieve this is such a big performance hit that no one even attempts to try to do this anymore. So we can't just put the entire world in a transaction. That's not how the real world works anyway. So we just can't try to just extend that line out there. So instead, we have to build our systems and the communication to assume that these different calls will fail, and then plan for the worst according to what happens when those other things fail. So luckily for us, there were much smarter people that had seen these kinds of problems in distributed systems and had delineated different options for how to deal with these different kinds of failures. And the classic paper on this is from Gregor Hope. I think that's how you pronounce it. His original paper was Starbucks doesn't use two-phase commit. I think Starbucks noticed that and said, please don't use our name in this weird paper. And so now it's your coffee shop doesn't use two-phase commit. And in this paper, he walks through a real-world scenario of you walking into, maybe not a Starbucks, but a coffee shop, and then how those coffee shops deal with the messiness of a distributed system, which is you, the person buying something, the cashier, as well as maybe someone also processing the order or making your coffee behind the scenes. That's a much messier system than just a single in-process operation. And so he looked at that real-world system and said, when things fail between these different handshakes and handoffs, what are the different options for dealing with those failures? So given any 2 resources where I have to coordinate some kind of activity, what are the 4 different ways we can address those different failures? Option 1, if I'm trying some operation with resource A and some action with resource B, is to just simply ignore the failure. So if resource B action fails, just ignore it for whatever reason. Now you might say like, well, didn't we just say we don't want to ignore failures, right? We want to take people's money. So this may not, that may not be an option for a lot of the different systems we talk to, but it could be. For example, do you want your system to go down because you can't write to your log? Probably not. So if something goes wrong with logging, you probably still want to be able to take people's money. So there are some cases where we will be talking to external systems where we just don't care if those other systems fail. They're not critical for the business. Option 2 is to retry that operation. That is, I perform some operation with resource A, I do some action with resource B, it fails, and instead of giving up on it, I just try it again. Now, there is a lot more detail behind being able to do retries. I have to worry about, can that operation actually be retried in the first place? So we have to do some investigation to make sure that if I try that operation again, it can actually be retried. We also have to worry about what happens if I retry and it fails again. Do I just retry forever? Probably not. So we'll have to think about how we want to handle a case where something is constantly failing. Like, what if SendGrid went down for a day? Do we just retry and retry and retry with all these processes hung? Probably not. So we'll have to worry about some kind of policy around how we retry. The next option is to have some kind of undo action. That is, I try an action with resource A, I try an action with resource B fails, so I perform some kind of undo with the action from resource A. Now, this could be something like a database transaction rollback, but it may not. It may be some kind of compensating action where I'm taking a new action to undo the action of that previous thing. Now, the final one is the most complicated one, which is to have this idea of a coordinated transaction between these two resources. Now, there's lots more arrows in this one, but the basic idea is that I split my coordination into two phases. One is the prepare phase, and one is the commit phase. And each resource is talking back to some kind of coordinator to be able to handle and manage that communication and those different operations. Now, you've actually have probably seen this in real life. If anyone here has had to purchase an apartment or purchase a house, that operation of you going and buying involves this coordinator and these transactions and this two-phase approach. So if I'm going to buy a house, there's usually some kind of a third-party broker involved, and there's usually some kind of deposit. There's also an agreement on the seller that says, yes, I want to sell this for this amount. And so this third-party coordinator is talking to each of the interested parties to say, yes, do you want to sell this house at this price? Do you want to buy this house at this price? Yes, you do. Yes, you do. Okay, now let's go ahead and sign all the papers. So this is a possibility in the case where each of these different resources can have this kind of communication, but it does come at a cost and an expense. In the real world, the cost is like money. I have to pay this third party to be able to just like watch me sign papers. But in our distributed systems land, you can see that the more their arrows are going around, the more communication that has to happen. And so there's an overhead to be able to do something like this. It also introduces the possibility of more failures that can happen. So I want to make sure that all those arrows are very solid and not like a broken line arrow or a dotted arrow. That these things will absolutely succeed. It's not a bulletproof protocol either. In that second round, after I do the commit, if that second commit to the second resource fails, then again, the system is in an inconsistent state. So it's not perfect, but it can be able to provide this kind of coordinated transaction between two different resources. So these are our 4 options dealing with failures between two different resources. So Bill and I had a master plan where we take each of those external resources, examine the possibilities based on those 4 different options, and pick the best option based on what was technically feasible, as well as what was most desirable from the business perspective. Now, this is where you do actually have to involve the business in your discussions. You can't just decide, oh, well, we'll just do a retry, because that may have implications for the end user, as we'll see. And anytime we're affecting the end user experience, we do need to involve the business to say, hey, if we retry this, the user may see this in their bank account, that sort of thing. So we need to make sure that we involve the business in these discussions. Oh, more systems failures next door. All right. All right, first up was Stripe. So 4 options, again, are ignore, retry, undo, and coordinate. So the first up is to ignore. Again, just a reminder, these are the 6 lines of code we had before. So what would it look like to ignore a failure of Stripe? Probably like a try-catch around calling Stripe, and then when the exception happens, just swallow the exception. But we kind of want people's money. We do need to get their money in order to fulfill their order, so just like ignoring failure from Stripe is probably not what we want to do. And in fact, I don't think I'd even talk to the business about this. They just give you this weird look like, why are you coming to this? Why are you coming to me with this option? Just get out of my office. So we probably don't want to just ignore failed payment. However, I bet that you have seen this in real life. I bet you have seen a case where a payment failed and the business is like, don't worry about it, you're good, it's okay. I've seen this sometimes, especially in places where that credit card machine fails, like it can't connect because of whatever reason, and the person that's performing that has an option, like, well, do I just go ahead and give them the food? Or do I say, no, we need to wait for other payment or you have to give me cash, that sort of thing. So in our electronic world, I probably don't want to ignore it, but in the real world, this kind of thing does happen. Option 2 is a retry. Now, this is where we have to be careful, because if I'm making a call to Stripe, remember we said that even though the Stripe call may have failed from our perspective, that doesn't mean it actually failed on the server side. Because we could have called Stripe and waited 30 seconds or a minute for a response, nothing came back, and we said, well, I guess it failed because they didn't get back to me. But it could have meant that I waited 30 seconds and not 31 seconds, or 60 seconds and not 61 seconds, because it actually did succeed on the server side. So in this case, we need to make sure that if I call Stripe again, that I don't accidentally charge the customer twice, because that's almost worse than not charging them at all, right? Like if you ever see getting double charged, you're probably going to be somewhat upset, and again, Yelp, bad reviews, et cetera, et cetera. So when you're dealing with looking at retries, you have to know how to Google for how to be able to do this. And the key word here for retries, in order to be able to try something more than one time and have it only happen once, is idempotent, or idempotency. The idea behind idempotency is that I can try some operation multiple times, and the side effect only happens once. Or I can try something multiple times, and it only happens once. So when I Google, like literally Google Stripe idempotency, their documentation come up. It says, yes, we do support this. And the idea behind idempotent request is Stripe can't really tell one request from the other. So if I have someone posting the same payment twice, it can't just look at the information and just assume that it's going to be a duplicate. So if it sees the same name, the same price, around the same time, Stripe still won't assume that that's the exact same request. It could just mean that someone just like clicked really fast or something. So I have to tell Stripe that this request has some sort of unique identifier to identify this attempted payment versus something else in the future. So this is an artificial idempotency as opposed to a natural idempotency. So if I tell someone to turn the light on, I can tell them multiple times, and if the light's already on, there's nothing for them to do. In this case, there's no sort of natural idempotency that's there, so Stripe says, you have to tell me some kind of unique key or identifier that distinguishes this payment versus something else. So we looked at this request and said, what is distinct about this transaction versus some other transaction? And we need to pass that information over to Stripe through this idempotency key header. So we looked at the request and said, what is the thing that distinguishes this business transaction versus someone just clicking really fast and putting something in their cart and hitting place order again? And it came down to the cart ID. You could also use the order ID, but it's basically something that represents this logical order that I can then pass over to Stripe to say, if I happen to call Stripe service twice with the same cart ID or order ID, then it only processes that payment once. But you have to explicitly do this. So by the way, if you're using Stripe today, like, do look at this, because if someone double clicks or something like that, this will catch those problems and just make sure that the customer only gets charged once. Because you have people like my mother who double clicks everything on the web, everything. Now this just allows this to be retried, but you don't see any code around here that actually performs the retry. So we still have to figure out, like, well, what is actually actually calling this over again? So there's none of that here. We just said, well, we're able to do a retry, and then we'll figure out how the retries actually happen sometime in the future. Option 3 is undo. Now this one is a little bit trickier because you have to think about what is the logical undo or compensating action for whatever action you were performing. And so there's nothing really like easily Googleable with this. You just have to kind of think, what is the action you're performing, and is there an equal and opposite action that you can do to undo the actions that you did previously? So in our case, we're looking at Stripe. What is the logical undo of posting a payment? I can have, like, there's credit versus debit accounts. In this case, I'm posting a payment, and so their concept of undoing a posted payment is a refund. A refund is a call that you make to Stripe where you give it the original payment ID, and it will post the payment back to that person's account from that exact same amount. So it would look something like this, where I would have that same set of code where I was trying to call all these different services, and if something fails, then what I'll do is go ahead and call Stripe again to refund the payment. There's still something missing here, though, because I had that transaction that was around everything. So in this case, I'll actually pull in the transaction as part of this operations, where I'll say, begin the transaction, do all your stuff, commit the transaction, and if something fails, then I will say, go ahead and call the Stripe service to refund the payment and roll back the database transaction. Now, I know some of you are looking at this and says, well, what happens? Jimmy, you said I should never say what happens if something fails. What happens when something fails? What happens when the Stripe service refund fails? Okay, let's go on to option 4. I mean, you gotta see, like, it just starts to get in a rabbit hole of all these different things that can fail, so we would have to worry about that in the future as well. Okay, option 4 is coordinate. Now, we said earlier that most modern web services aren't built with any kind of like transactional support in mind. It's assumed that whenever I call the API, that there is a transaction behind the scenes, but I can't coordinate like more than one call, nor can I coordinate this call with some other thing that's going on. I can't coordinate a transaction with Stripe and SendGrid. That's just not possible. So I looked at this and said, well, do they have some kind of coordinated activity that's a two-step flow where I prepare the payment and then I actually commit the payment later on? And it turns out they do actually support this. It's called a two-step payment flow. If you've ever gone to a hotel where they ask for your credit card, they'll put a charge on it for like a night's room or something like that, but it won't actually post to your account. If you log into your account, it will say pending transaction, and the transaction will be pending for like the length of your stay, and then when you check out, they'll either deduct whatever that you've purchased, or they'll just remove that authorized payment, and it never gets posted to your account. And so we could do this, where we have a two-step payment flow. In this case, what we'll do is we can call Stripe initially to authorize a certain amount, and then after everything else has succeeded, then we'll go ahead and post the payment. So it looks something like this. Well, I have the same try catcher on everything, but this time instead of just me posting a payment, I'll first post an authorization to pay something. And then if everything succeeds, then later on, I will go ahead and post the capture down at the bottom. Now again, we said, what happens when this second call fails? Actually, if that call fails, we're actually in not a bad state. Because if something happens here, I can log something, and then the Stripe administrator can log into the Stripe admin user interface, and they can see all the Stripe payments that have not succeeded, and they can go and say, click capture, 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 capture for all of those. So it is able to kind of be in this half okay state, and then administrator can then go fix things later on. Okay, so that was Stripe. Now, Stripe is going to look a lot different from the options that we'll see from SendGrid and RabbitMQ, because Stripe is, it's about money, right? So we want to make sure that those things are very successful. But SendGrid and RabbitMQ are very different. They have a lot different guarantees that they'll have for their services, and they're optimizing for different kind of usage scenarios. So looking at SendGrid, option 1 would be to ignore this. Now, this is where we can go to our business and say, what happens if SendGrid goes down? Is it okay if we still process their order? Do we want to fail the entire order process if I can't send them an email saying thank you for your order? Business may say no, or they may say yes. I don't know. Usually they'd say no, like I don't want to prevent my business from taking money if I can't just email people. That seems a little bit silly. So in this case, ignore could be a viable option. So it looks something like this. Where instead of me calling the SendGrid service directly, what I'll do is I'll wrap it in a try-catch, where I'll try the SendGrid service, and if something fails, then I'll just log an exception. If I do need to actually send the order success email out, then I may do some more processing to like flag the order needing an email or something like that to have something process it behind the scenes. But the general idea is that I don't couple myself in this case, to SendGrid's uptime. If SendGrid is down, it'll just go on and keep on going. Option 2 is a retry. So you can Google this. You go SendGrid idempotency, SendGrid retries. And what you'll find is a lot of Stack Overflow questions with no answers, but like 20 comments, which that's a bad place to be in, right? Like if you Google something and Stack Overflow has no answers but just comments, then you're like, I'm in trouble then. So there's no such thing as idempotent requests for SendGrid. There's a good reason for this. So SendGrid optimizes for speed. So when you call SendGrid, it's going to send that email as fast as possible. Now think about Stripe. Now Stripe, I want to be able to handle like calling the API multiple times. So every time I call it, if I pass in that key, it's going to have to look up in its list of transactions, have I charged this customer before? Now SendGrid, if it's optimizing for speed, it doesn't want to make these lookups to say, oh, have you sent this email before? Let me go check. Oh, there it is. Don't send the email out. So for SendGrid, that's not part of its business model, so it's not going to allow these retries. So if I call SendGrid twice, those emails will get sent twice. So we don't want to call SendGrid twice unless we're OK with duplicate emails. Now this is where I talk to the business, and I ask them, would you rather have at like a 0 or 1 email sent out, so like it either succeeds or fails, and if it fails, I don't send it out? Or would you want to have at least 1 email get sent out? So if I try it more than 1 time, there's a possibility that the user gets more than 1 email. And of course, the business says, neither. I want it to happen exactly once. But distributed systems, there's no such thing as exactly once. We can try to put that in there, but it's just impossible. So we're left with this choice of, do we want at most 1 email go out or at least 1 email, and have to leave it to the business to decide which one is the most appropriate option. Option 3, undo. As much as I would like to be able to undo emails, we can't unsend emails, right? There's no, like, click the button. I guess Gmail has this now, doesn't it? Like, you can unsend an email, and how does it do that? Well, it just doesn't send the email right away. It just waits 10 seconds to say, I won't send this email right away, so you have about 10 seconds to change your mind. And if you change your mind, I won't unsend it. I just won't send it at all. But we can't retract emails as much as I want to. So what's the compensating action here? Sorry, we screwed up. I've had to send these emails before, I'm sorry I screwed up emails to customers. It's not fun, but that is a compensating action from the business we can do. Sorry about the problem. Let us compensate you with a coupon or compensate you with bonus points or something like that. So we could have some kind of business level compensating action, but not from the like low technical perspective. Option 4, coordinate. I don't even know what that means for email. Like, how would you like? I'm going to put my finger on the email, and then I'm going to do the transaction. And when this thing succeeds, I'll lift my finger off the email, and then it gets sent out the door. Like that's not a thing that happens with email. So there's nothing for this. Finally, is RabbitMQ. Now, RabbitMQ is going to be very, very similar to email because RabbitMQ deals with messages. So we kind of have a very similar kind of options available for us, but our decision about what to do may be different because in this case, the things we do with RabbitMQ may be more important than just sending someone an email. So option 1 would be to ignore. This would look, again, like I have a try-catch around trying to talk to RabbitMQ, and if something fails, then I still need to notify downstream systems. So what I'll do is I'll just flag the order as needing to have this thing sent out the door so that some kind of like maybe a background process looks for orders that need to have their message sent out the door, and then just once a day or maybe once an hour, whatever it might be, looks for those orders and then go ahead and finishes this operation. So this could be a possibility for us, but we still need to have something that is sending those messages out the door. Option 2 is a retry. So RabbitMQ and some brokers do have a concept of a retry. If anyone here has used Azure Service Bus, Azure Service Bus has duplicate message detection. You have to turn it on, and what it'll do is we'll keep track of messages for a certain period of time, like 30 seconds, 5 minutes, some kind of configurable amount of time. And what it'll do is every time I call to send a message, it will check to see if it's sent any of those messages in the last amount of time, and if you already have, it won't send the message. However, just like the web service, if I wait longer than that, then that message will get sent out the door. So in this case, like RabbitMQ doesn't support that kind of operation, so RabbitMQ doesn't have a concept of a retry. If I try a message again in RabbitMQ, it will get sent again. Now, RabbitMQ doesn't have any concept of retries, so I don't have to worry, I don't think about what RabbitMQ is going to do with those retries. I have to think about what all those downstream consumers are going to be able to do with duplicate messages coming in. So this is one of those things, like if I don't have control over these other consumers of these messages, then I may not be able to do retries at all and just say, I can't guarantee that those downstream systems will be able to handle duplicate messages, so this may not be a possibility for us. Option 3 is undo. Just like emails, we can't unsend a message. I can't like take the message back and like notify everybody, oops, I'm sorry, please don't do, well, like ignore that last one. And then a compensating message would be weird. I have the order placed event, and then right after that, like, haha, just kidding, order wasn't really placed event. That's not a thing that people do. And so in this case, the compensating message would be weird. There are cases where this does happen. Let's say that I have an order that was placed, but then the customer calls and said, I made a mistake, can you cancel that order? And then depending on where the order is in the order process, I'll have different actions I can perform. So like from the business perspective, they may be able to do something like this. That's where you start to come into different policies and business rules around each of these different actions. Option 4, coordinate. RabbitMQ does not support this. No real broker out there supports this kind of operation anymore of coordinating transactions. Some of the more older brokers and queues do, but they perform horribly. When you're using something like MSMQ and SQL Server, you can actually coordinate a transaction for both of those resources, but it's like 10 times slower when you do so. So for our systems, that's not a performance hit we're willing to take. And so for modern brokers, they just don't support this kind of operation at all because it's such an expensive thing to do. So looking at all the different services and all the different options, like there's not any consistency about what things are supported between each different ones, and the business rules are now getting really wonky about all these different things. And if I tried to encode all of this into that one set of 6 lines of code, it'd be these like nested try catches, and if something fails over here, then I have to do some operation over there. But if that still fails, then like, oh God, we still have to recover from that. So this is where Bill and I took a step back, and we said, this is getting too complicated. Like maybe the main problem here is not that these things can fail at any point in time. Maybe the main problem is that we're trying to do all of these operations in a single button click. We're trying to do too much when that user clicks that button. So can we avoid exceptions by breaking this process coupling and stop trying to do so much in the context of a single button click? Now, I've actually worked in e-commerce. I've worked on a very large .com website in the cart checkout operation, and so I know like what real businesses do with this. And what we'll be describing from here on out is how these large organizations actually solve this process coupling. So in order to figure out what things can be broken out, we have to look at each of these different operations and ask the business, does this thing need to happen when the button is clicked, or can it happen sometime in the future? And that's not, again, a decision that I can make as a developer, but I have to pose that question to the business. Do I have to do this now, or can we do it sometime in the future? Do we have to do it when they click the button, or do we have some kind of background processor that can take up these things? The first up is Stripe. So this is, again, a business discussion, because in some cases, we may need to try to charge the customer when they click the button. But there are other cases where we may not want to. Amazon, for example, they don't charge you when you click that button. There's some kind of background thing that works to be able to do that. And the reason why they have that is because they have like effectively infinite supply or inventory. And so there's no need to say like, well, I can only allow a certain number of people to be able to buy this thing, so I need to make sure that when you click the button that I take your money right at that point in time. But there are other cases where they do try to take your money at that point in time. So something that has a very finite amount of resources, so something like a movie ticket, where I'm picking a seat where I want to sit. So in that case, they want to make sure that from the business perspective, they're only selling seats to people that actually pay. So in that case, they'll do things like have that little timer that stresses me out, that's counting down from 5 minutes. It's like, you must pick your seat and put all your information in there. And what they're doing is reserving a seat and making sure that you can actually pay when you hit the button. But in our case, in this actual real-world application, we went and talked to the business, and they're like, you know, it would be nice if we could take their money, but it's not required. We won't have to take their money at that point in time. So in this case, what we did was we did a try where we said we're going to try to take the money, and if something fails, then we'll just mark the payment as failed, and then some kind of background processor will be looking for orders with failed payments, and then we can try to retry them at that point in time. Next up was SendGrid. We asked the business, so what does SendGrid need to be actually connected to? What is the thing in this process that should kick off or initiate me emailing the customer? So I said, is it when we insert an order into the database? Is that the thing that should kick off this email to the user? Like, no, not really. It's not as important that we have the order. It's actually when they pay for it that we should then send the email out. So I said, okay, is there a way for us to connect SendGrid with Stripe so that when a SendGrid payment is successful, then we go ahead and send the email? And we can do this using webhooks. You can also do this if you use things like Logic apps or whatever the Amazon version of this, or if this, then that. These kind of like event-driven widgets that says, when this thing happens, go do this other thing. And so we looked at Stripe that has the ability of a webhook that says every time a Stripe payment is successful, call this API over here, and then you can do whatever you want in that API call. Unfortunately, for our real-world scenario, this wasn't good enough for us. So while it's nice that it's there, we needed to have more kind of business logic that happened for the email, and so this wasn't an appropriate solution for us. The final one was RabbitMQ. We said, when I create this order, do I want to couple the uptime of RabbitMQ to me processing this order? And again, this is a question for the business. We do need to send this message out eventually, but they're not necessarily a case that I have to do it at this point in time. So the way we can separate out RabbitMQ from our database transaction is to use an outbox pattern. And the outbox pattern, I messed that up, would basically store the messages temporarily in our database. So when I create the order, I'm not just inserting the order information, I'm also inserting messages into like a messages table. And then something behind the scenes is looking in the database for messages to be sent, and then we'll send them out the door via RabbitMQ. So in code, it would look like this, where instead of me calling bus.publish, instead, I'm inserting something into our database that is that message is eventually going to get sent out the door. And then some kind of background processor is going to look for any kind of unsent messages, and then we'll actually take the messages off the database and send it out the door via RabbitMQ. Again, we were still not quite there because we looked at that final set of code, and it was still just not very explicit about all the things that were happening there, and it's just, again, a bunch of try-catches around everything else. So we looked at it and said, we're still just doing way, way too much in the context of a single button click. And if we looked at modern e-commerce systems, modern e-commerce uses background processing to actually fulfill the orders. So what we need to do is introduce some kind of workflow to manage the processing of the order and remove as much responsibility as possible from that initial button click. But as part of this, we're still going to have some constraints around these different operations. So I looked at each of the different services we were talking to and said, what are the things that need to happen as part of each individual item? So Stripe, we said, do we need to do this now, or can we process this offline? So in the case of Stripe, our business said, we want to minimize the checkout fallout rate. The fallout rate is someone that starts the checkout process and then abandons it and says, too much junk is going on. I'm tired of this thing blowing up at me, whatever. So in this case, what we'll do is try to minimize that as much as possible by moving the Stripe processing from the button click and doing that offline instead. And this is what we actually did in my real .com e-commerce experience. We even turned off all validation, like all of it. You know those annoying things you'd see, the credit card, if you accidentally switch two numbers, it's like, that's not a valid credit card number. It's called the LUN check or the loon check. There's a built-in checksum into credit card numbers that you can use to check to see if it's a valid credit card number or not. Users hate to see that message. Because like they thought they entered it in right, and they just switched two numbers, and it's saying that's not a valid credit card number. And like, yes, it is. So now you have to take your credit card out, like put it up next to the screen, and be like, oh, there's where I messed up right there. So when I worked in .com or e-commerce, we just turned all that off, like all of it. So that if someone messed up entering their credit card, we would call them sometime in the future, say, oops, we couldn't process your credit card payment, and actually talk to a human to be able to then finish that order. SendGrid and RabbitMQ are very similar in that there's no requirement to process these or to do these things in the context of a single button click. So all of these things, we're not actually required to do in the context of that one single button click. So these things now need to be coordinated on some kind of background process or workflow. So let's go to see. I'm going to skip this actually, starting that. Yes. So it looks something like this. We'll have requests come in, and the only thing that thing does now is just insert a row into the database. And then something is then pulling those information off the database and kicking off some kind of processor behind the scenes, some kind of order processor that then coordinates the activities between these different backend services. Now, at this point, we need to figure out like what is that workflow look like. We didn't want to go like buy a workflow solution off the shelf; it's too expensive. So we'll be writing code to figure out how to go ahead and process the orders. And there are a few different workflow patterns off the shelf that we can look at to be able to process those orders effectively. The first pattern is known as the routing slip pattern if I'm in the UK. The routing slip pattern is this idea that I have a message with all the different destinations, and then that message just flows from one endpoint to the next until it reaches its final destination. So it looks something like this, where that background task would post the message first to the Stripe messaging endpoint. Once Stripe finishes processing, it gets forwarded on to the next process, and then once that finishes, it gets forwarded on to the next one. And then the thing that kicks everything off will just say, send this message to all three of these different endpoints. Now we looked at this one and said, well, there's still some workflow constraints we have. Like, SendGrid should only happen if Stripe succeeds. But RabbitMQ is a different story. Maybe that doesn't have that kind of coupling available. So this enforces a very linear flow, but for us, this workflow process didn't need to have that linear flow, so it wasn't a very good fit. Another pattern is the Saga pattern. In the Saga pattern, the canonical example is booking a holiday. And the general idea is you can't coordinate the transaction of all the different parts of booking a holiday into one single transaction. So if I'm booking a rental car, booking a hotel, booking a flight, you can't get like a conference call with all those three people together, right? Like, no one ever does that. So instead, I have to book each individual thing separate from each other. So it starts out with, okay, I'll book the rental car, that was successful. Next thing I'll do is book the hotel, that was successful. But if I fail in booking a flight, then what I need to do is cancel the reservations of the other two. So this kind of simplified flow works really well if I have compensating actions for those different operations, but we've already seen that two of our operations don't have compensating actions. Like I can't unsend an email, and I can't unsend a message. So this Saga pattern works well for very simple business scenarios, but ours is more complex. This is not going to work for us. Now, the final pattern available to us is going to be the process manager pattern, which is basically none of the simple stuff works, and so now you're just completely up to your own device about building out some kind of workflow process. So in this case, we'll have some kind of central thing that manages the overall order processing pipeline, where it receives notifications that a new order is ready to be processed, and is now coordinating communication between these other third-party services to fulfill the entire business order. And again, we have another choice in front of us. What does that coordination actually look like between that central process manager and these other things going on behind the scenes? And from the microservices world, there are two main patterns that are identified for this kind of process management. They're known as orchestration and choreography, also known as like command-based versus event-based. Command-based is going to be very procedural in its look. It's going to be some process manager saying, hey, do this thing. Okay, now thing 2, go do this thing. Okay, now thing 3, go do that other thing. And choreography is more event-based, where I just publish an event, it gets broadcast to all the different subscribers, and then I wait to hear back what the results of all the different processing was. And my choice between each of these is really going to depend on that process coupling. Do I need to make sure that this thing happens first before other things, or does it not matter the order in which things get processed? So again, I have to go back to those list of things that were happening and look at the process coupling. Stripe, I need to make sure happens first before I do anything else. I don't want to send a thank you email unless that payment was successful. So in this case, I actually want to orchestrate the call with Stripe to make sure that that thing happens first before I go do any of the other operations. SendGrid, I don't need to tie to anything else. So for SendGrid and for RabbitMQ, I can actually use choreography, that is event-based notification for those. So it starts to look like this. We have the initial request coming in from the outside world via post to our API. And that set of work, the only thing that's doing is inserting a row into a database, and that's it. So I have a high confidence that that can succeed. Like if I can't insert a row into a database, then like I can't do anything else in my system. So we want to make sure that that operation has a high degree of success. So we'll want to make sure that that database is highly available, maybe primary, secondary, or some kind of replicated mode, to really make sure that I can insert rows into a database at any point in time. Now from there, something then looks for orders that need processing and is going to kick off our process manager. So our web code now looks like this. So we've removed those 6 lines of code and just basically boiled it down to like 3 lines of code, which is first, go ahead and create the order from the card information. We'll save the order to the database, and then we'll send a message to kick off this background process to actually do the work. So that message to kick off this set of work is going to be sent to our process manager to be able to take that and actually perform the operation. So the next part is then receiving that message and then coordinating with Stripe to actually perform that first step in the process. So in this case, I'm using a library called InServiceBus to make this part easier. I don't want to code process managers by hand myself. So in this case, InServiceBus just kind of removes a lot of that plumbing junk to make my life a bit easier here. So it looks something like this, where I have this process order Saga, which is a process manager implementation. It receives the process order command that came from the front end. It's going to do some logging, and then all it's going to do is then send a message to the Stripe payment processor to go ahead and process that order. So it receives the message from the outside, and it's going to send the message out to Stripe to say, okay, I've received the order, now go ahead and process that payment. Then on the Stripe side, it's receiving that notification to say, you need to now process this payment. It's going to make the call to Stripe to process the payment based on the information it finds, and then based on the success or failure of that, it's going to return that back out and reply back to the original process manager to say, this is the result of trying to process this payment. So inside that await Stripe service process payment, you can probably imagine some kind of like try-catch that says, if Stripe fails, then just go ahead and return back a result of false to say it wasn't successful, and then we'll leave it up to the process manager to decide how to deal with failures. So my Stripe processor is not the thing that's managing what to do with failures. It's merely returning the result of the operation to let the process manager have all the business logic of what to do. So that reply comes back as a new message to the process manager, and the process manager then receives that message and they can make a decision. So if I want to put in some kind of retry policy for Stripe to say, let's go ahead and try this Stripe call again, we could send another message to Stripe to be able to do so. Or if I want to say, try it 5 times, wait a day, try it 5 times again, that could all be done in the context of my process manager. But if it's successful, then I can notify these downstream systems. So it looks something like this. Receiving the process payment result, I will check to see the success or failure of that payment. So if it didn't succeed, this is where I have the business logic of what to do based on that. So in this case, I just saying, let's just mark the payment as failed. We could do something like try the Stripe payment again, keep track of it inside my process manager. But if it's successful, then at the bottom what we'll do is go ahead and publish out a message saying, okay, Stripe succeeded. We'll go ahead and say, notify downstream systems that our order was accepted. So the final piece is the RabbitMQ and SendGrid part. But I noticed that SendGrid just needs to be notified when payment was successful. So SendGrid could actually just be another subscriber to this event that payment is successful. Just like all the other downstream systems, like any kind of fulfillment service in the back end. So SendGrid just becomes yet another subscriber to that payment successful event. So the thank you sender, this is the SendGrid service now, the SendGrid endpoint, receives the order accepted event based on the publishing and says, okay, now I will go ahead and send you the thank you email based on that order being accepted. And that order accepted event, it doesn't care why that happens. So it's not connected to the business logic about when orders or why orders get accepted. It just gets notified when this occurs, okay, then go ahead and perform this additional operation. And all the other different downstream processes are also connected to the same individual event. So the fulfillment services or shipping services, they're also connected to this order accepted event. So I wind up a picture that looks like this. And this picture is this is more complicated, right? Like I'm introducing a lot more things into the mix here. Instead of having everything happening in the context of a single button click, now I'm introducing messaging. I'm introducing communication patterns with request response and pub sub. I'm introducing this pattern in the middle of this process manager. So this is a lot more stuff to do. But with this in place, I have a much higher degree of success of orders actually getting processed. And when I worked in a large e-commerce shop, this is exactly what we did. We didn't use queues because they didn't exist at the time. We had a table that just had order requests and an is processed flag. And we would just loop over the table. So we basically invented a queue as part of our order request process. And we had an order processor that did exactly this. It would walk through all the different things that needed to happen with an order and coordinated the operations of each of those different things. So this is where Bill and I got to at the very end. He felt very good about things. But we looked at this picture, and we only had 1 week left on the contract. So this is too much to do. So in real life, the choice we actually picked was about 40 minutes ago. Sorry. In real life, we actually went with the undo action. So we would try to post a payment to Stripe, and if that failed, then we would just refund the money, because that was all that the business had appetite to do. But in modern e-commerce systems, they start to introduce these more complex interaction patterns to be able to have a much higher degree of success with the most important part of the business, which is taking the customer's order. So if you want more information about this, the best resource that I have for you is the poorly named, but it's a great, great book, Enterprise Integration Patterns. And so all these different patterns we've talked about, the person that wrote this, Gregor Hope, also did that coffee shop doesn't do two-phase commits. And so all the patterns I described here are actually documented as part of this, along with much, much more. So if you're interested in reading more about this, I encourage you to check this out. It's not like a Dan Brown book. It's not like a page turner. It's very thick. It's a patterns book, right? So you don't just read it front to back. It also doubles as a personal safety device. So it's very large and thick. So if you're getting robbed, you can smack someone with it. But it is a great book to have around. So thank you very much. This was 6 Little Lines of Fail. I hope you enjoy the rest of your conference. Thanks.